And while everyone's getting up there, I'll just say thank you for the kind words, Sarah. And we're only 4 minutes behind our schedule, so this is pretty good. So what I'm going to do over the next few minutes is I'm going to sort of lay out sort of why the Lit Lab, or what the Lit Lab is, rather, why the Lit Lab, and then we're going to have the students actually show you some cool stuff. So the majority of our time will actually be spent with them showing you cool things. And forewarning, we're going to encourage you to pull out your cell phones and your laptops because they have some live demos, fingers crossed, for you to actually play around with. And then after that, we'll come back and we'll talk a little bit about where we see things going in the future. All right, so what is the Lit Lab? So aside from a great excuse to have a logo that incorporates both the flame of knowledge and vernacular usage for something that's cool, the Lit Lab is basically, we sort of operate in several different ways, either through classes or through the Lit Fellows, to basically serve as a consultancy to groups both inside, being our own clinics, and outside the law school, and provide both legal tech and data science services. So what in the heck does that mean? Well, the legal tech side's pretty easy to understand, or at least conceptually not that difficult. That's, all that efficiency stuff, document automation, robots are going to take our jobs, et cetera, that sort of thing. The data science is something that's a little more personal to me, and where I came from directly preceding this, I saw some representatives here from CPCS, which is my old home, the public defenders here in Massachusetts, where I was the data scientist there. So we try to incorporate those, and you will see at least one data science project when the students present. So you may know this guy, right? So Garry Kasparov, great chess player, interesting in the history of what we're talking about here, because at one point, some folks at IBM said, let's have you play a chess-playing computer, and we'll see how that goes. Well, first time he plays, he wins. He's like, that was easy. They're like, give us a year. He comes back, he plays, the computer wins. Okay, well, really, it's just, running through all the different possibilities, whatever, blah, blah, blah. But chess is not dead, and it's not even dead for Garry. He's actually invented something new. After this experience, instead of just saying, oh, I'm giving up on chess, he's actually created a new form of chess, which he calls centaur chess, where computers and teams of computers and people play together, doing things that I'm told in the chess world, rival heights unknown, right? The point is that we're much better together than we are alone, and that this idea of technology versus the attorney is sort of a false dichotomy. So, the elephant in the room, big data and the law. Oh, come on. That was some major Photoshop skills, I'm telling you. So, big data is the thing we use to feed machine learning algorithms. And what in the heck is machine learning and AI? Well, it's really just statistics. And this is from a presidential report administration ago, back when we still had I'm not allowed to say, well, there was a science office. There was a science office. And they put out a thing on AI and machine learning. So it's really just a statistical process. At the end of the day, machine learning is really just sort of about making predictions or making classifications, at least sort of in its current iteration. There's this wonderful statement from Amy Hoy, I think, who says that a machine learning model under our current definition, this is a machine learning model, y equals mx plus b, telling you where the line's going to go. And she's not that far off. If you look at, this is some data from some Virginia court data that I've played around with in the past, and you can see here there's the seriousness of a charge on one axis and the income of the defendant on another, and then you can see sort of spread out where all the sentences fall down. And you can see that as the income goes up, the sentences go down. And as the seriousness goes up, the sentence go up. That latter one you'd like to think is the case. That other one, it's not surprising, but it's there, and you can see it when you plot things like try to put a plane through there, and then basically what you're doing with a lot of machine learning algorithms is defining what that plane is, figuring out that best fit, which is all just by way of saying that really, when we're talking about machine learning, and I'm doing this preface here so that my students don't have to get into it, and they can just go right into some of the cool work they're doing. Here's an example from self-driving cars. So this is Stanley, one of the self-driving cars that competed in the original, this was the second DARPA Grand Challenge. And basically, they knew how bumpy a road was or how steep a road was, and they wanted to go slow when it was really bumpy or really steep. Right? And so you can see slow or fast is either red or blue, and that's just all the data collection of when they wanted to go slow, when they wanted to go fast, if a human driver was driving. And so what they had to do with machine learning was figure out where is that line between slow and fast, which is to say that a lot of machine learning is just line drawing. Okay, I sort of glossed over it and did a bunch, but it's line drawing. This is not something new to attorneys, and this is the type of thing we need to be working with our students on. So one thing I want you all to remember is all models are wrong, but some models are useful. So an important thing to keep in mind whenever we're looking at what the students are working on and what we're working on in legal tech, mostly we're talking about building models, and those models need to be evaluated under this rubric. So you should remember, since they're wrong, they should always start the conversation, not end the conversation. Okay, this is the problem you get into with these black box algorithms, where they spit out an answer, no one can talk about them because no one knows what's going on. And then, if they're useful, you have to ask compared to what. So you have to look at the current state of things and see where this stacks up to that. So why are we doing this in the clinical setting? Well, because, as Andy so eloquently put, this is the future, and this is about how people are working today. So these things are happening now. So this research group in China put out a paper on figuring out the criminality of people based upon their face. Sounds a lot like phrenology. And if you don't know enough about what's going on, you can't question these things. Okay? And at the end of the day, it's all about algorithms and figuring out what is it that you count as fair, what is it that you want to work with. And as we know, that should be easy, right? Just figure out what fair is. Well, as Gill v. Whitford in front of the Supreme Court recently showed, the gerrymandering case there the question is, what is it you're maximizing for? And what is fair? And I really think that's a case that's an algorithmic fairness case that's been talked about as a gerrymandering case. But I have talked way too much. What I want to do is have the students talk about the cool work they're doing. So the point is, when you're looking at what they're doing, remember, start of a conversation, not the end of a conversation. And how is this compared to what's already out there? Those are the touchstones. And you're going to be, I can't oversell this. I'll just let it speak for itself.